Imagine stumbling upon ancient giants from millions of years ago, not through dusty expeditions, but by spotting vibrant orange patches from the sky. Sounds like a plot from a sci-fi thriller, right? But here's the mind-blowing truth. Everyday organisms, like lichens, are now helping paleontologists unearth dinosaur fossils in unexpected ways. And this is the part most people miss. It's not just about finding bones. It's about how nature's tiniest collaborations could transform our understanding of prehistoric life. Let's dive into this fascinating discovery and explore how it might change the game for scientists worldwide. First off, for those new to the concept, lichens aren't just pretty growths on rocks, they are remarkable partnerships, or symbioses, between fungi and algae, or sometimes cyanobacteria. These miniature ecosystems thrive in diverse environments and play crucial roles in ecology, such as helping to break down rocks, or even acting as air quality indicators. What makes this research so exciting is that lichens have been found to colonize fossils, particularly in Western North America, serving as natural markers that can be spotted using advanced remote sensing techniques. Picture it like nature's own treasure map, where these orange-hued lichens guide us to hidden dinosaur remains. But here's where it gets controversial. Could this reliance on modern biology to uncover the past overlook the importance of traditional fieldwork? Some might argue that embracing tech shortcuts diminishes the thrill of hands-on exploration, potentially sparking debates about preserving the human element in science. Nonetheless, the study reveals something groundbreaking. Certain lichens preferentially grow on dinosaur bones, covering up to 50% of exposed fossil surfaces, while barely touching the surrounding rocks. Why the favoritism? It boils down to the bone's unique properties. They offer alkaline, calcareous, and porous substrates that these lichens love. For beginners, think of it like how certain plants thrive in specific soils. Here, the calcium-rich dinosaur remains create an ideal habitat, making the fossils stand out like beacons in a sea of stone. This phenomenon, noted anecdotally by experts for decades, has now been quantified in research led by Dr. Brian Pickles from the University of Reading. As he puts it, it's astounding that these tiny ecosystems are built atop the remnants of creatures that roamed Earth over 75 million years ago. And this is the part most people miss. The meadow of orange lichen often catches the eye before the bones themselves in areas like bone beds, where fossil concentrations are high. To put it in perspective, imagine wandering a vast canyon and noticing a bright orange blanket. That's your clue to dig deeper. Enter the cutting-edge technology. Drones equipped with specialized sensors that capture aerial images at a fine 2.5 centimeters resolution. These devices detect the lichen's distinct spectral signatures, lower reflectance in blue wavelengths and higher in infrared, allowing researchers to identify fossil sites from above. This method holds huge promise for paleontological searches, especially in rugged, remote terrains where ground surveys can be perilous or time-consuming. For example, think of isolated deserts or mountainous regions in Western North America. Traditional hikes might take days, but drones could map these areas swiftly, speeding up discoveries while cutting costs and minimizing the environmental footprint. It's like swapping exhaustive manual labor for efficient, eco-friendly scouting. The roots of this idea trace back to observations from the 1980s, when paleontologist Darren H. Tank suggested that the orange hues on Centrosaurus bones could one day be visible from satellites. A visionary prediction that's now reality thanks to drone tech. Dr. Caleb Brown from the Royal Tyrrell Museum of Paleontology emphasizes that this pattern, once just a hunch, is now backed by solid data. And Dr. Derek Peddle from the University of Lethbridge adds an exciting layer. This groundwork could soon expand to larger-scale mapping with aircraft and satellites, using these lichen indicators to scan immense landscapes for fossils. The potential here is enormous, blending imaging innovation with expert knowledge to push dinosaur discovery forward. But let's ponder counterpoint. As we lean on technology, are we risking overdependence on it, potentially missing subtle clues that only human intuition catches? It's a debate worth having. Does this tech enhance or overshadow the art of paleontology? This groundbreaking study, detailed in a paper by Brian J. Pickles and colleagues, was published this week in Current Biology, accessible at https://www.cell.com/current-biology/full-text/S0960-982225-01206-0. It marks a pivotal step in how we connect the dots between the present and the prehistoric past. What do you think? Should we embrace these high-tech shortcuts to uncover Earth's history, or do they come at the cost of losing something irreplaceable? Do you see potential downsides, like privacy concerns in remote areas or impacts on wildlife? Share your thoughts in the comments. I'm curious to hear differing opinions.